Now, for our design unit, we're continuing with collecting and processing of information. This is our lesson 5. Of course, we still have the unit Big Idea. The engineering design process is a systematic, iterative problem solving method which produces solutions to meet human wants and desires. Now, the lesson Big Idea. Computers assist in organizing and analyzing data used in the engineering design process. We're using computers. One comment that someone made in another classroom, and we were talking about our final test. And one thing they said, yeah, we have 3-hour exams by hand. Ours is not by hand, ours is on the computer. That does save a lot of time. Now, is anyone else's exams online by computer or just certain ones like the CTE ones? How about you all's math exam? I think that would have to be by hand. And computers assist in organizing and analyzing data. So computers can be time saving. You do have to know what you're doing with them though. Why do we need data? To learn? Yeah, huh? Okay. To store? Okay, you're storing your data so you know what's going on. You have that data so you can analysis. I can't hear you, Jacoby. Huh? Okay. Throughout the design process, the design needs to be continuously checked and critiqued, and the ideas of the design must be refined and improved. Each time you're comparing your criteria to your basic design. What is your criteria? Is this design meeting that criteria? You're going to go back and you're going to check that and you're going to recheck it. And what are the constraints? You're going to go back and check. You have to make sure you're in status. Statistics can be used to help optimize your designs and improve your efficiency. Statistics. That's one form of math. Another form of math. See? Statistics is numerical data collected, organized, and analyzed. Okay? Mm-hmm. Oh, now which math are you in? Covering statistics. Oh, good. So everybody gets part of statistics. Because you're using your numerical data, you're collecting your data, you're organizing it, you're analyzing it. Now, it's also used in manufacturing. What's the probability of this happening versus something else happening? Now, statistical analysis, some of the terms that we look at. So please pay careful attention to these. The mean, the median, the mode, standard deviation, range, and tolerance. Now, if we're looking at our statistics in our manufacturing site, we're going to have an upper specification limit. We're going to have a lower specification limit. If you've got a door that's on a controller, say, a controller is what talks to your computer. It's sending signals back and forth between the controller and the mainframe. If you've got a door that's going to open, or even the door in a building that's going to open, it has an upper limit on the size of that door, and it has a lower specification limit. If you go outside of those specs, the door may not open. because it's too tight. It may not fit in the opening. If you go to the lower limits, then you may see a gap like that on the side of the door. The door is closing, but you've got a gap on the side of it. Now, the mean. The mean represents the average of a set of data. So to get the mean, you sum all the data in your set of data. You divide it by the number of items in your data set. Okay? That's the mean. What's next, guys? What's the median? What does it say if it says the median? The middle is right. Huh? Okay, the max. The max would be the highest. Say again, quarter. Okay. Okay. Well, good. You all are doing statistics. Doesn't it make you feel good? But at least you know this part already. It's easy now. Median is your middle number. So you need to put it in numerical order and see what number is in the middle. When the data set has an even number of elements, the median is the average of the two middle numbers. Okay? The mode. The mode is the most frequently occurring number in a data set, and you can have more than one mode. For this data set, we have one mode. But if we had several numbers listing another 3 or another 5 or even another 1, we could end up with 4 modes. So it's possible to have more than a mode. The standard deviation. This is the spread of the set of data. Now, the higher the number, the larger the spread. So you've got your figures here, and then you go to some numbers here, then you jump to some more numbers over here. And when you've got that long set of numbers, then it will determine what your value is. The higher the number, the larger the spread of data. Standard deviation is calculated using your formula. X minus the mean, the square root of x minus the mean, that summation. So it's x minus the mean squared, give the summation of that, divided by n minus 1. So for the numbers that we have, our average was 5, and we had, they go from 1 minus 5, and you can see your calculations there. So your standard deviation is 3.08. The range, huh? Yep, with the fancy calculators now. A calculator's a computer, isn't it? Yep. The range. The range represents the maximum value in the data set. Subtract it by the minimum value in the data set. I would have said take the maximum value, subtract the minimum value from the maximum value, and you get your range. They just said it differently. Same results. Your tolerance. Your tolerance represents the possibility of error in measurements for a data set. Your tolerance is half of your range. So you take your range, divide it by 2, and you get your tolerance. Your upper spec limits. Your upper spec limit is the largest measurement, a part of clearance space is allowed so that the part still functions. Remember we were talking about the door. If you're past the upper specification limits, your door may not close. So you've got the frame on the side of the door, and you need to make sure you stay within the specs or your door won't close. If you're on the lower tolerance of your specs, then the problem that you have is the door may close, but you've got a gap there and you don't have the privacy. So your parts are not functioning well. Now, in your engineering design journals, you're going to calculate the following for the data set on the left. I'll create that as an assignment so you don't have to calculate it right now. Okay, guys? Is that good? Computers and statistics. As you've experienced in our exploration activity, you can enter formulas into Excel. Has anyone ever used formulas in Excel? We may look at that. That'll be a project for us. To evaluate your data and information that you want to communicate, computers and calculators can be used to access your data, retrieve your data from where it's stored, organize your data, and it's also storing your data, maintain and interpret. As Miguel was saying, one of the things is the fancy calculators. You've got formulas in those calculators. You've got formulas in your Excel spreadsheets. That is how you're getting some of your data processed quickly. Some are programs that's been written on the computer. Microsoft Excel is a common program used to enter and formulate your data.